Howdy, IB. It's Ms. Kosh. I was asked over email to help with a few questions, so I highlighted them and worked through them a little bit, and then want to talk about them. So I don't remember which ones they were, but I'd gotten 2 different emails. So one of them, and in no particular order, here we go. This appears to be page 282, number 9. So what I did with this one is I had to back up and think about Bayes' theorem, and Bayes' theorem makes a whole lot of sense to me when I draw the tree diagram and label the corresponding parts. So basically, what we're trying to figure out is how do I find the probability of A given B? I want red. The probability of A given B. So that means we know that B is true, so we're either this scenario or this scenario. What's the probability then that it came from here? Well, so we have to find the probability of B as my denominator, and then find the probability that it's A intersect B. So it's this part over that. Well, the way that we get there is we say, well, we have the probability of A times the probability of B given A. That's equal to this value. And then, so this is Bayes' theorem. We can also then rewrite how we describe the probability of B. Well, so looking at the tree, we can figure out probability of B means that I came out to here, and so I have this value, or I came out, had not A, then B, and came out and got this value. Well, so how do I get here? I say the probability of A times the probability of B given A, and this one is the probability of not A times the probability of B given not A. And if you notice, that's what has been maybe rewritten in a different order, but that's what's in the denominator there. So I was looking at that and trying to figure out what was happening. So then what I realized, as I wrote more stuff anyway, I erased some of it, but here's a lot to work with. What I realized is that the probability of B given A times the probability of A, well, so that means the probability of B given A is this thing right here, times the probability of A. That's the intersection, that equals the intersection of the two things. So this, if I have the probability of B given A1 times the probability of A1, that's equal to the probability of B intersect A1. And then the next one, I can use that same idea to get the probability of B intersect A2. Then it's the probability of B given A3 times the probability of A3 gives me the probability of B intersect A3. Well, notice that becomes, I'm not sure, I might be missing a step here. So if I've had a few critics on YouTube lately, so if you know more than me, you're more than welcome to link to a video of yourself explaining this a little bit better than I am. I'm exhausted. This year has been the roughest to the worst year in my 21 years of teaching, but you know, it is what it is. Okay, that aside, what happens was it's the intersection here, the intersection, you add those together and you get all of B. So I think I might be missing a step between here and there, but I've not seen IB ask a question like this in the past, and who knows. So I need somebody smarter than me to tell me what I'm missing. All right, let's go to the next one. On this one, they tell us that we've got a class of 25 students. We've got some 15-year-olds, we've got some 16-year-olds, we have people that own a dog, we have people that own a cat, we have people that don't have any pets. So I started making a Venn diagram. Well, so we have 15-year-olds and 16-year-olds. They are mutually exclusive. And then we have, well, and we know that there's a total of 25. So when I added those two, I got 23, so that left us 2 out here. But they don't tell us anything about the relationship between dog owners and cat owners and age. And actually, what we really know is that there's more to this Venn diagram situation over here. So maybe it looks something like that. Maybe it looks like, maybe we've got people, because when you look at this, when you look at the numbers, you have 8 that own a dog and 7 that own a cat and 4 have no pets. So that means of the 25 students, 21 of them have an animal, but we've only accounted for 15. So there could be a world out here where there's 6 students that own fish, or I don't know what they own. So yeah, it actually would look like that because, well, no, I mean, it could overlap like this. There's more happening here that they didn't give us enough information about. That would just mean if it looked like if it did include this circle that I just drew, then that would mean that this entire circle here would still, for dogs, would still have 8. So it just would, anyway, but yeah, it's fine. Point being, find the, if, it says here, if possible, find the probability of F union D, that they're 15 and they have a dog. We don't have enough information. So, I forgot to look at, somebody asked about number 8, and I didn't think about it. Okay, let me see. Do you know what? Let me do the ones I already thought about, and then I'll come back if I remember. Okay, so the next one, they said, find the probability that here's this lovely little tree diagram, and the question was, the person was confused about, is not an officer in the Navy. So I went Navy, officer, and that, when you multiply those things, you get this 0.0418. So everybody else is not an officer in the Navy. So I added all those up, and that's the number I got. So basically what I did is I said 1 minus 0.22 times 0.19. So hopefully that makes sense, and that's where we got that answer. There was another one that somebody asked about and I thought about. In a group of 50 students, 40 study mathematics, 32 study physics, and each student studies at least one of these subjects. Okay, so I went through and used this where the number, I used N instead of P because we don't have probabilities yet, but that's the number of elements in math union physics, or the number of elements in math, the number of elements in physics, the number of elements in math and physics, that intersection. So I plugged in the things I knew, and I figured out that there had to be 22 here. And then I started working the studies mathematics, but not physics. That's these people. So it's 18 out of the, I was about to say 40. 18 out of the 50. There's a total of 50 people. That reduces. On your quiz, because I'm letting the computer grade it for me, I would want the reduced fraction. The IB test wouldn't care if you write it this way, but since the computer's grading it and I'm exhausted, go ahead and reduce your fractions. Really and truly, that's the story. Number 2 from part B, studies physics given that he or she studies mathematics. So now we're living in the world of only the mathematicians, and so 22 of those 40 study physics. Okay, let me go back and see the one that I haven't thought about. You get to watch me think. Suppose A and B are mutually exclusive and that A prime and B prime are mutually exclusive. Find A union B. Okay, here's what happens. If A and B are mutually exclusive and not, well, okay, so then that could look something like this. So here's A, here's B, they're mutually exclusive, life is good. But what they're saying is that A naught and B naught are mutually exclusive. Well, I'm going to shade A naught roughly. Pretend I can color within the lines. This is why I don't teach kindergarten. I'm kidding. Okay, that's A naught-ish. So let's pick another color. I don't know how that's going to go on top. Let's try this. And let's shade B naught. So here's B naught. Are those mutually exclusive? This is where you answer me and tell me no. They definitely had areas where they overlapped and that sort of thing. Okay, so what happens here is we have to redefine our idea of what that should look like. And so in order for A and B to be mutually exclusive and A naught and B naught to be mutually exclusive, they have to be together. The union of them has to be the whole set. Okay, it doesn't have to divide it in half necessarily. You could have 1,000 elements in this one and 1 element here. That'd be fine. But basically what's happening here is that if this region here is A, then that means this region here is A naught. And if this region here is B, then that means that this region here is B naught. And now A and B are mutually exclusive, and A naught and B naught are mutually exclusive. Therefore, the probability of A union B, that's everything, is going to equal 1. Okay, I hope that was helpful. Good luck. Keep studying. Keep practicing. Work hard. Goodbye.